So there are two ways in which you can actually work out time. You can use the calculation part, or you can use this line diagram that I have here. So we know that, alright, let's start with the line graph. Over this side will be the west, over this side will be the east. The rule is that every 15 degree on a line of longitude is equal to 1 hour, right? And every degree is equal to 4 minutes, right? And once you're going to the east, you add time. Once you're going to the west, you subtract time. So just like how you would track the time of places in Europe, Japan, China, they will be ahead of us because we are in the western hemisphere, they are in the eastern hemisphere. So let's apply this one now. So it says if it is 11 p.m. Sunday, December 1st at 90 degrees west, so we're going to find 90 degrees west, which is right here. So this will be 11 p.m. What time will it be at 60 degrees east? So we know that we're going all the way over here. So let's go now. So because we're going to the east, we're going to add. So this would be 12 midnight. Then we have 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m., 7 a.m., 8 a.m., 9 a.m. Right? So the time here would be 9 a.m. But then guess what? It's a new day because we jumped past 11 p.m. So it would be now Sunday. Sorry. It would be Monday, December 2nd. Let's look at this example here. B. So we have at 45 degrees west and 90 degrees west. So we already know that 90 degrees west here is 11 p.m. I want to find the time at 45 degrees west. So guess what? We're going to go in this direction because we're going to find it right here. Once you're moving towards the east, even if you're in the western hemisphere, it means that you're going to add as we have it here. So we'll move. This will be 12 midnight, 1 a.m., 2 a.m. So the answer here would be 2 a.m. And remember that we passed 12 p.m. Sunday, so it's going to be a new day, Monday, December 2nd. So this is in terms of the line graph, right? So let's look at the actual calculation now. So when you're doing the actual calculation, you first of all look at the two hemispheres. If the hemispheres are of different positions, so like if you have west and east, you're going to add. So you'd have 90 plus 60. You add those two together, you get 150. Then you're going to divide 15 into 150 in order to get the total number of hours. Once you divide that, you get 10 hours. So now you're going to say to yourself, if you're going to 60 degrees east from 90 degrees west, which is over here, it means that you're going to add the 10 hours to the 11 p.m. right? So 11 p.m. plus 10 hours, that would be equivalent to 21 hours or 21 o'clock if we call it like that. And if you convert that to actual time, it would now be 9 a.m. just like the answer that we got before, right? The same principle would apply over here now, but guess what? We have two same hemispheres here, west and west. So we're going to do the opposite, subtract. Once we do that, we are left with what? 45 degrees. 45 into 15, we're left with 3 hours. So we're going to say to ourselves now, are we going to add or subtract these 3 hours? The fact that we're going to 45 degrees west, which is right here, we're going to add. So we add 11 p.m. plus 3 hours. That will be equivalent to 14 o'clock, which is the same thing as 2 a.m. just like how we got it.